Hi folks, Mr. Long here. We're going to continue on with video number 3 for the ambiguous case. All right, so I just want to briefly go over this number 2 again. So in number 2, we went through it previously, and so I'm just going to bring this to here and this to here. So if we notice the measurements on this triangle that we're working with here, angle A is 24 degrees. So that angle up there at A is 24 degrees for that triangle. And the side opposite angle A, which is side A, is 40, so that's over here, and 30 here. So we look at this and ask ourselves, is this a reasonable orientation for this triangle? What do you think? Well, it doesn't look very good because the 40 certainly wouldn't be longer than 30. So it looks as though this triangle is not correct. So there's another triangle over here that the orientation might work. So if we look at it, side A, which is always opposite angle A, is 40. Side C, which is always opposite angle C, it looks like it's 30. So that's much more reasonable, right? Because we know that side C is shorter than side A. So it looks like this is our scenario. So side C is going to be 30. Side A will be, sorry, side C will be 30. Side A is 40. So let's go to our spreadsheet and work through it. So in this time, side A is going to be 40, and side C will be 30. And we're keeping the angle at 24 degrees. So first thing we would do is substitute into the cosine rule. Okay, this is our side-side angle case. And now we know that there's really going to be there should only be one side length that works. And so when we put everything into our cosine law and then simplify it, rearrange it for the quadratic formula, we get this. Go through, get the discriminant, and the discriminant ends up being 76.19. So there are two solutions to the quadratic. But if we look here, when we go through the quadratic formula, we get one solution that's 65.5, but our other solution is negative 10.7. Can the length of a triangle be a negative number? No, it can't. So really we only have one solution that works. And that's what we would have thought, because we would have thought there was one triangle. So even though the discriminant is positive, only one of the solutions makes sense. And we can look at a picture of that to make sense of it. So if we remember this right here, we have to be able to get a second triangle. We have to take that side length, BC, rotate it, and have it intersect AC, and it doesn't. So really, I think what that negative 10.6 is measuring is maybe how far this goes out here. I don't know, though. I've had a hard time conceptually imagining what that is. But the fact of the matter is you cannot have negative distances. So we only get one triangle that works with the quadratic formula. Okay, so to finish that one up, all you'd have to do is, since you only need to have one of them at 65.5, then you can go through and there's only one triangle. There's not two triangles. And you work through it the same way as you did the previous example. Substitute all your values in, solve for cos C. Get what cos C is, and work backwards to figure out what angle B is by looking at the interior angles summing to 180. Okay, that's a very quick overview of that. What I want to do again is go back here and look at another triangle. So if we look at this, the first triangle had two solutions. The second triangle had one solution. It looked like this. The discriminant was still positive. Now, this third solution, there's something interesting here. If we think about this, what I want you to look at is say, okay, so I've got side A is only 3. Side C is 12. So I'm going to insert some text boxes. So it looks like side C is 12 and side A is 3. So, okay, so it's shorter. It definitely is shorter. Like this side here, side A is shorter than here. So maybe it's possible that it can go through its arc, intersect again. But there's a bit of concern that I have. There's another couple scenarios possible. Maybe it's a right angle triangle. Or maybe, let's look at this one. Maybe the 3 isn't long enough to even make a triangle. Okay, to even make a triangle. Okay, so in that case, since this side's not long enough to touch AC, we wouldn't be able to make a triangle, so the discriminant in that case should be negative. And by the way, the angle's still 24 degrees up here at A. So let's take a look and see to see what happens. So if I go to this one, we said the length of A was 3, and the length of C was 12, and the angle's still 24 degrees. So, like I always do, I substitute into the cosine law. I create a quadratic equation, and I try to solve it. And in this case, I get a negative discriminant. A negative discriminant indicates you can't get any solution that works. So let's go back and see what that tells us. Since the discriminant is negative in this scenario, that A of 3 is so short that it can't even reach A to C. Okay, can't even reach it. So since it doesn't reach, do we even form a triangle? No. Since there's no triangle to be formed, the discriminant is negative, which means there are no possible solutions. Okay, so again, summarizing, we had 2 possible triangles in the first one. In fact, we had 2 triangles. The discriminant was positive. In this scenario, we had a positive discriminant, but there was only one triangle that was reasonable because the other one had a negative x value. And then in this one here, there was a negative discriminant because we couldn't even form a rectangle. Now, the last scenario is one that's very hard to do mathematically. We're going to go to this one. You have to go to so many levels of decimal place accuracy to be able to do this. But you can see that we had a scenario with 2 triangles, 1 triangle, no triangles, which is a negative discriminant, and then that looks like a right angle triangle. So let's see what happens when I put this data into the spreadsheet. That's 5. 12 is the side, and the angle is, let's go back, the angle is 22.61 on, whoops, that's actually 13. 22.61. Enter. Okay, so we're going to go through our calculations again. So I substitute in. I have a quadratic formula, a quadratic equation, which I solve with the quadratic formula, but I do the discriminant. Look at that discriminant. 0. By the way, always feel free to pause, do the work, and then, come back and listen to the voiceover. So this right here, this discriminant of 0.08 is indicating that the discriminant is almost 0. So if I go through and do this, and I use the quadratic formula, because that discriminant is so small, look at this. I get x1 of 12.1 and x2 of 11.9. Basically, they're the same, right? They're basically the same, 12. So if I go back over it to get the angle, another angle, I notice I get 88.4 degrees. Well, 88.4 degrees is very close to 90. And the discriminant is close to 0. So when you get a discriminant in this scenario that's less than 1, in all likelihood, you have a right-angled triangle, right? Because if the discriminant is 0, there is only one proper solution. Okay, it's not like it has one of those, it has two solutions where one of them doesn't make sense. If the discriminant is almost 0, and it would only be almost 0 because of issues with rounding, that means you have one triangle. And if we look at the angle, we've got 88.4 degrees. If we went to all that work to go to the second triangle, which was 11.9, and did the whole thing, you get 91.6. So what I would like you to do is, if you get a discriminant that's less than 1, you can assume that it's a right angle triangle. And if you just want to solve it, when you get those two answers, what I would encourage you to do is just to average those two answers, okay? So if you get a discriminant that is less than 1, just take the two answers and average them. So that would be 12.0. So when you go to put it in, you're going to put 12.0 in there, okay? And that should, that's going to give you that right-angled triangle, okay? And then it's going to be very easy to figure out angles. So let's go back here. So that means that we get this scenario right here, okay? So if you see a discriminant less than 1, so between 1 and -1, actually, because of rounding, it could go either way. But you're going to get that scenario right there, a right angle triangle. Okay. So again, what you should do in this scenario is record the discriminant, record x1 and x2, then make a note that you're only going to average you're going to average x1 and x2 because the discriminant is so close to 0. So going back over that, number 1, 2 triangles possible. And in fact, 2 triangles exist. Scenario 2, positive discriminant again, but one solution is negative, one solution positive. The negative solution doesn't make a lot of sense. Third one, a negative discriminant because we didn't even get a triangle, okay? So we can see that it doesn't, in this case, this distance here isn't even long enough to touch that side. So you're not able to form a triangle. So a negative discriminant in this scenario means you just can't form a triangle. And in the last scenario, we ended up with a discriminant of like 0.08. And there's a lot of rounding in trig because of trig ratios. So really, when you get a discriminant between sort of -1 and 1, what it really means is a discriminant of 0. And so what we did is we ended up with x values of 11.9 and 12.1. So when we get in that scenario, we probably need to average them out. So we ended up with the other side length of 12. And that makes a perfectly right-angled triangle. So we have this scenario here. So when the discriminant is 0, you have a single triangle and it's right-angled. Okay, so this x1 would be 12. Well, this was 12 and 12.1. And this was 0.08, but you can kind of average that out to 12.0. All right, folks. So this is what your homework is going to look like, your practice questions. So you're going to do it all the same way. So there's your first question. Angle A is 42, side C is 17, side A is 12. And here are your answers right here. Okay, so your answers are there. So clearly there's 2 triangles, and you're going to solve those. And so on. Okay, so I'll ask that you do those 6 questions right there. And you might want to use the spreadsheet to help you in terms of laying out your solutions. But what you're going to do is take this information here, draw a picture of the triangle. Then you're going to use the cosine law with the quadratic formula to get the 2 possible side lengths. And from there, you're going to go ahead and figure out all of the missing angles inside in the either 1 or 2 triangles. Okay, so best of luck doing your homework.